Intel's Arc GPUs released almost 2 years ago, officially released. We didn't get to see dedicated GPUs like the A770 or A750 until the end of 2022. Arc's initial launch was rough due to poor performance caused by driver issues. Since then, Intel has put forth a lot of work to improve their drivers and is seeing increases in performance by up to 750% in some titles. So how are they in 2024? I had to see for myself and, of course, share everything with you. Believe it or not, Intel's hardware is a force to be met. On paper, these things look amazing, but we'll have to see if that transfers over to real-world testing. I've got a total of 4 GPUs for today's comparison, and all of them come in under $300 US. The first card in the lineup is the Acer Predator BiFrost A770. It's got a 2.2 GHz graphics clock, a 2.4 GHz boost clock, and it comes with 16 GB of GDDR6 memory. Now this runs on a 256-bit memory bus at 17.5 gigabits per second, which gives you an effective bandwidth of 560 gigabytes per second. I know those numbers don't really mean a lot to you now, but just try to remember them because things change as I move along the stack. The A770 runs at 225 watts of board power, so I wouldn't really call that efficient. The cheapest A770 I was able to find as of today's filming is this exact model. The Acer Predator BiFrost OC comes in at $284.99 over on Newegg after a $15 off promo code. Huge thanks to our friends over at Skytech Gaming who sponsored today's video. They provided the A770 that we used in today's testing to give us a wider look at Intel's Arc lineup. Of course, the other Intel card I used in today's testing is their A750 limited edition, which I picked up over on Amazon during their Black Friday sale for $180. It's got a 2050 MHz graphics clock and a 2400 MHz boost clock, which is the same as the A770. It does have 8 GB of GDDR6 memory, which is half of the A770's. They both run on a 256-bit memory bus, with the A750 at 16 gigabits per second. This gives an effective memory bandwidth of 512 gigabytes per second. Now it does require the same 225 watts of board power that the A770 does. The cheapest A750 I was able to find was over on Amazon for $209.99. It's the Sparkle ORC OC edition. I did decide to include both AMD and NVIDIA in today's testing. For Team Red, I went with the AMD RX 7600 reference style card. It has a 2250 MHz clock and a 2655 MHz boost clock. It also has 8 GB of GDDR6 memory, just like the A750. It has a 128-bit memory bus at 18 gigabits per second, which gives you an effective memory bandwidth of 288 gigabytes per second. Now that's a lot lower than the A750 and A770, however it also requires less board power at only 165 watts. The cheapest RX 7600 I was able to find was the XFX Speedster SWFT 210 Core over on Amazon, and it's $249.99 right now. For Team Green, I went with the Asus TUF Gaming RTX 3060 OC. This graphics card runs at 1852 MHz clock speed and 1882 MHz boost. It's got 12 gigabytes of GDDR6 memory on a 192-bit memory bus running at 15 gigabits per second. That gives you an effective memory bandwidth of 360 gigabytes per second. Now it also requires less board power than the two Intel cards at 170 watts. So pretty much on par with the AMD card. The cheapest model I was able to find was the Asus Dual OC in white for $284.99. That's over on Newegg. Now that you know what cards are in the lineup, let's talk performance. I ran a total of 5 games at 2 different resolutions, so you've got both 1080p and 1440p. You're welcome. My test bench setup is an AMD Ryzen 7 5800X3D on an MSI B550 Tomahawk motherboard. It's also got 32 gigs of Corsair Vengeance Pro running at 3200 MHz. Cooling the CPU is Deepcool's massive Assassin 4 CPU tower cooler. Some of you might think I should have used liquid cooling instead, but it worked just fine. Never past 60°C. The first title up was Forza Horizon 5. I ran the tests on the Ultra preset, which enables ray tracing to high and MSAA 2x. I also turned off upscaling technologies to see native performance numbers. These are the results of a 3-run average for each. At 1080p, the RX 7600 takes the win with 115.4 FPS and 94.5 for the 1% lows. The stack rolls down from there with the 3060 hitting 94.1, the A770 at 90, and the A750 at 86.2. The RX 7600 keeps the lead at 1440p with 95 FPS average and 79.9 1% lows. Intel's cards are quite a bit behind, but so is the 3060. Forza seems to favor AMD. Let's look at another title that's more neutral. I used to run Apex Legends in all my benchmarks, but I've kind of drifted away from it over the past year. I decided to bring it back in my first test for 2024, so let's see what they've got. I used maxed out settings because it's a fairly simple game to run. The winning slot at 1080p is a little more crowded in Apex, as the 7600, 3060, and A770 all compete for first place. The difference between them is run-to-run variance. That, and you won't notice a 2 FPS difference at all. 1440p is more of the same, where they all got within 3 FPS of each other, right around that magic 144 FPS mark. I do want to note that even though the RX 7600 had the highest FPS numbers, it also had the most stuttering and lag. Look at those 1% lows. Cyberpunk 2077 was next, and I used the built-in benchmark to keep things consistent. I ran the high preset with no upscaling or ray tracing, and crowd density on medium. At 1080p, the RX 7600 takes the win with 95.9 FPS average and 74.4 1% low. The A770 can't quite make it as it sees 83.9 and 67.6. It catches up, however, at 1440p, achieving a perfect tie with 61 FPS average and 50 for the 1% low. Of course, Fortnite has to be included in all my testing now. This was using DirectX 12, high preset with nanite, lumen, and ray tracing turned off. Also, I used native resolution, no upscaling. The RX 7600 wins at 1080p again with 117.9 versus the A770's 105.2. The 3060 seems to be more of a direct competitor, matching with 103.6. Switching over to 1440p, the A770 closes the gap to within 5 FPS of the 7600. The last game up is Hogwarts Legacy, and I wanted to use this title because the 8GB VRAM has not shown any issues so far. This was ran on high preset, which enables RT to high quality. At 1080p, all the GPUs run the game fine, but the 7600 is the worst of them this time. When I switched up to 1440p, that's when things got interesting. At native resolution, the two 8GB cards could barely run, as most of the testing was horrible and jumpy. They only managed to hit about 34 FPS with even worse 1% lows. This is where the RTX 3060's 12GB and the A770's 16GB were really able to shine. They had no problems running this at 1440p native resolution. The A770 got up to 46 FPS with 23.9 1% lows. Even though it's not that magic 60 FPS number, it still produced good gameplay. I decided to enable upscaling technology to see if I can improve performance a bit. This brought the 8GB cards to a playable experience and improved the larger capacity cards to over 60 FPS. The VRAM limitation I experienced during Hogwarts Legacy is an interesting one, and something I wouldn't mind exploring later on in future content. If that's something you want to see, don't forget to hit subscribe down below and turn on that bell icon so you'll be notified when that content goes live. Gameplay on ARC was great. I had no problems with stuttering or crashing, except on the A750 when it ran out of VRAM in Hogwarts Legacy. But the A770 was the smoothest card of the whole lot. Well, I should give credit to NVIDIA because the RTX 3060 did just as good. In less demanding titles, the RX 7600 may have taken the FPS win, but don't count out Intel Arc. It wasn't that big of a gap, and the performance hiccups the 7600 experienced when it ran out of VRAM was kind of a big deal. I saved features and software till last because it could take up a whole video of its own. I'll try to keep things short and simple. Intel's software has improved immensely. I didn't have these cards back when they released, but other reviewers stated that their software and user interface was so bad that it was totally unusable. When I installed both GPUs to my test bench, all I had to do was Google Intel Arc drivers, hit the download here button, and wait for installation. I had no issues with failed installs, complications, or overlays not allowing me to multitask with other windows. It seems like Intel has fixed all the complaints they received during launch. This brings me to features. Intel has really put forth their best effort when it comes to making their entry into PC gaming solid. Both the A770 and A750 come with AV1 video encoding, which helps capture smooth streaming or video recording. I tested this to capture my Hogwarts Legacy gameplay. ARC can also enable ray tracing in games without a huge performance hit. In fact, they have better RT performance than AMD. If you want to boost your frame rate, they also include an upscale technology called XESS, which is kind of like NVIDIA's DLSS, except not as good. Yet. What kinds of features do you look for in a GPU? Do you like to see those ray trace reflections in games? Or maybe enable upscaling technologies to achieve those ultra high frame rates? Maybe both. Well then, what are my impressions of Intel's ARC GPU lineup 18 months after release? I, for one, am impressed. They've priced these cards so well, they compete with AMD's value, and they offer build quality and features rivaling NVIDIA. I may not have had to deal with the headache when these came out, but I did get to see how smooth the experience was today. And of course, I didn't get to test every game and use case scenario for these Intel ARC cards, but I feel like I gave it a good showing. If you're looking for something for under $300 that has lots of features and you won't have to upgrade your GPU in a year or two, don't sleep on Intel. I'm glad I didn't. And as I always say, I'm Danny with Danny's Tech Channel, and I'll see you in the next one.